Welcome to our lesson on 11.9. In our previous lesson, we looked at how to draw diagrams for plane mirrors. In this one, we're going to be looking at how to draw diagrams for curved mirrors. So in a plane mirror, remember that we had a solid line and lots of little lines on one side of it. The solid line part of it, that is what we call the reflective surface, and behind it was the opaque side. For curved mirrors, there are two types of curved mirrors. There is concave mirrors or converging mirrors, or convex mirrors or diverging mirrors. So those are our two types of mirrors. Just like we did for plane mirrors, I'm going to be showing you how to draw images for both of these types of mirrors. So let's start off with diagrams for concave mirrors. Before we get into the rules and how to draw the light rays, let's look at some basic terminology. So I've got my concave mirror in front of me, and something you'll notice in all of our diagrams is this line that passes through the middle. This line is called the principal axis. I'm also going to have 2 points that are identified on the diagram, one being F and one being C. The relationship between these two is that C, the length of C from the mirror all the way to C, is 2 times the distance from F to the mirror. Okay, so if I know F, I can automatically know C. Another way to write the same thing is that F, or the distance of F from the mirror to F, is half of that of the distance from the mirror to C. So F is actually what we call the focal point, and C is center of curvature. The distance between F and the mirror is called the focal length. So that is just some basic terminology for the diagrams that we will be seeing for all of concave mirrors. Now, the whole point of this arrangement is so that we can look at how images are created. The difference between concave mirrors and plane mirrors is that there are a lot of different possibilities. So if my object is farther away from the mirror, there is a different image created than when it's at C. Or there's going to be a different image created when it's between C and F, or a different image created at F, and a different image created between F and the mirror. So there are a total of 5 different scenarios, so 5 locations where the object might be. That gives us 5 different options for where the image will be. And we're going to go through each of these scenarios so that you can learn how to predict where the image is going to fall. And after we draw these, we can describe the image using SALT. If you remember from last time, S stands for size, A stands for attitude, L stands for location, and T stands for type. All right, so let's take a look at our first scenario. So in the first scenario, our object is beyond C. So it's very far away from the mirror. Now, there are a set of rules or a set of lines that we have to draw in order to determine where the image is formed. The first line that I'm going to be drawing is going to start at the top of my object. So my object is this arrow right here. It's going to start at the top of that object and go all the way towards the mirror. One thing that I want to be careful for is that the line that I'm producing has to be parallel to the principal axis. So you want to make sure that you're using a ruler, and you want to also make sure that you are producing a very straight line that's parallel to the principal axis. And then after you've drawn that, the second part of this line, so as soon as it hits the mirror, you're going to then line up the point where it hits the mirror and F, and draw another line coming backwards. Right, so remember that this is a mirror. So you have See? So you've got your incident ray going towards your mirror, and it's coming back this way. So that's the first line, or first set of lines that I'm going to draw. After I've done that, I'm going to draw another set of lines. So I'm going to start at the top of my object. I'm going to line up my ruler through F, and then I'm going to hit the mirror. So my next line is starting at the top of my object. It's going all the way towards F, through F, hitting the mirror, and then it's going to come back, but this time it's going to come back parallel to the principal axis. So it's going to come back this way. Right, so I've got my green set of lines that started at the top of my object towards the mirror. It comes back through F. My second set of lines starts at the top of my object, goes through F, hits the mirror, and then comes back parallel to the principal axis. Now where these two lines meet, specifically this point right here, that is going to be where the top of my image is going to be. So I've got an arrow right here. The top of my arrow is going to be where these two lines meet. And that's how I'm going to draw my image. So I'm going to use that eraser so that you can actually see. Oops, okay, so I lost all of that, but you can see the image that's actually being drawn there. Now that you have your image, let's try and describe the image in comparison to the object. So using SALT, you can use, so S stands for size. So this object that I started off here and compared to here. The image that I have is smaller than the object that I started off with. So I'm going to write smaller. Attitude can be upright or inverted. The image that we have is inverted. Location refers to where on this particular diagram the image falls. And this is why it's crucial to understand the terminology that we went through, because we can now describe the image to be between C and F. Now the last one, T, stands for type. So that's referring to virtual or real image. If you remember back to our lesson on plane mirrors, we remember that when we draw our image on the other side of our mirror, the lines never actually met. So the light coming from the object was reflected off to the mirror, and then it came to our eye, and then our eyes interpreted that image to be behind the mirror. The reflected rays never actually met where the image was formed. In this scenario, these lines are meeting up, and that is where my image is formed. That tells me that this is a real image. And I'll go through that as we do the rest of the scenarios as well. So if you were looking at a concave mirror and you have an object placed beyond C, you're going to see an image that's going to be between C and F. It's going to be inverted, it's going to be smaller, and it's going to be a real image. All right, let's look at our second scenario. We're going to be doing the same set of lines that we did for our first scenario. So in this case, the object is at C. So we're looking at our mirror there. So my first set of lines that I'm drawing starts at the top of my object, goes towards the mirror, comes back through F. So I'm just going to emphasize the arrows here. So going towards the mirror, coming back towards F. Second set of lines starting from the top of my object, going through F, hitting the mirror. So it's going towards the mirror, and then coming back parallel to the principal axis. Oops. That's where. Okay, and where those lines meet, that is where my image is going to be produced. Of all of the different scenarios that we are drawing, this one is probably the most difficult one, and that's because you want to be very, very careful for the parallelness of the lines that you're drawing. because if not, you're going to get the lines meeting at a location that's not at C. So it's the least forgiving of all of our different scenarios. So you want to make sure that your lines are parallel and that they are passing through the exact points of where we're talking about. So let's describe the image. So the size of the image is going to be the same. The attitude is inverted. Location is at C. And type, it is real. Moving on to our third scenario. So in this case, the object is between C and F. The same set of lines in this as well. So starting at the top of my object, going back towards the point F. Second set of lines, starting from the top of my object, going to F, through F to the mirror and then back. Where the two lines meet, that is where the top of my image is going to be, and it's going to extend all the way back to the principal axis. Now, so let's compare the image to the object. So size-wise, the image is larger, attitude is inverted, location is beyond C, right? So this image is located beyond C, and type, the light rays are converging, and that's where the image is formed. That is going to be a real image. So for scenario 1, 2, and 3, we've been using the same set of lines. For scenario 4, it's going to be a little bit different. So my first set of lines is going to be the same actually, so I'm going to draw that. So it starts at the top of the object, going back towards F. Okay, so that's the same. Now my second set of lines requires for us to match up the top of the object through F, and that's not actually possible because in this case the object is on F itself. So the second set of lines that I'm going to draw is going to start at the top of my object, and then I'm going to line it up with where the principal axis and the mirror meet, so right there. So I'm going to draw my incident ray going to that point. So it's going towards that point. And then that line is going to be reflected back. So it's going to go away from the mirror. So just to keep in mind that when you're drawing something like this goes back to our law of reflection. The angle of incidence that we have here is going to be equal to the angle of reflection that we have here. So just keeping in mind that those two angles are the same. So you're not just drawing a line that's going randomly this way. It has to be in this way. Now, if you look at these two lines are parallel to each other, which means that they are not going to meet. If those two lines don't meet, I'm not going to have an image formed. And that is going to be the case anytime you have an object on F, you actually don't have an image formed at all. Okay, moving on to scenario number 5. In this case, the object is inside F. What I mean by that is that the object is between F and the mirror. So I'm going to draw the same line that I've started off with for all of these diagrams. I'm starting from the top of my object going towards the mirror, and then the line comes back so that it can pass through F. That is my first set of lines. My second set of lines, again, in this case, just like the previous scenario, I cannot draw a line between the object and F because it's actually closer than F. So what I'm going to do, just like I did in the previous scenario, is line up the top of my object to that point where the principal axis meets the mirror. That's going to be my incident ray. And that line is going to be reflected back, just like that. Again, keeping in mind that my angle of incidence is equal to the angle of reflection. Now, unlike the previous scenario, this green line that I have here and the blue line that I have here are not parallel, which means that they are going to meet. Are they going to meet on this side of the mirror? No, because they're moving farther away from each other. So what I'm going to do is extend these lines behind the mirror. And just like we've always done, when I'm drawing a line behind the mirror, I'm going to draw it as a dotted line. So I've got these two dotted lines, and they do meet behind the mirror. The point where they meet, that is where my image is produced. So let's compare my image to my object. So let's describe it using SALT. The size of my image is larger, right? The attitude, so I'm comparing if it's upright or inverted. They are both facing the same way, so they are both upright, the image is upright. Location is behind the mirror. And type. So when I talked about real images previously, I mentioned that the light rays have to be meeting, and that's where the image formed. In this scenario, just like our scenario for plane mirrors, in this case, the light rays are not actually meeting each other. The lines that are meeting are a projection made by our brain and our eye. So in this case, because our light rays are not coming into contact with each other, this is a virtual image. So I'm just going to repeat what that means one more time. In a real image, the light rays that are reflected, so this particular line and this particular line, they would meet, and the point where they meet is where the image is produced. That is what we call a real image. In this scenario, they don't meet. Instead, what our brain does is interprets those lines meeting behind the mirror. And that's why we draw these as dotted lines, and that's why we see an image behind the mirror. So in this case, this is a virtual image. So just to summarize all of what we've done, so all of the 5 different scenarios, I want you to go back to the note, look at everything that or all of the diagrams that we've done, and I want you to fill in the SALT for each of these different images produced when the objects are at different locations. So when the object is beyond C, what does the SALT look like? And so on and so forth. So pause the video, fill it in, and then come back, and then I can show you the answers. Okay, I'm going to show you the answers. So this should be your chart completed. So we're going to switch gears and look at diagrams for convex mirrors. So just like we did for concave mirrors, we're going to explain the diagram setup, if you want to call it that, for a convex mirror. Just like we did for concave, there's a mirror there. There is a principal axis. We've got our 2 points F and C. Now, this is a huge difference between concave and convex mirrors. In the diagram for a concave mirror, the F and C points were on the reflective side. In a convex mirror, the F and C are on the opaque side of a convex mirror. The relationship between F and C are still the same. It's still the focal point, it's still the center of curvature, this is still the focal length. Okay, so the key difference between the concave and convex mirrors are the location of the F and C. So in a concave mirror, it's on the reflective side. In a convex mirror, it's on the opaque side. All right, unlike the concave mirror, regardless of where the object is for a convex mirror, the diagram is still the same. So it's not like you have to learn or remember 5 different scenarios. There's just the one that you have to remember and understand. And if you do that, you can draw your image, which you can then use to describe the SALT of that as well. All right, so let's look at this one scenario here. So if you have your object in front of the convex mirror, the lines are going to be different than what we've drawn so far. So just listen carefully and follow along and make sure that you're drawing this on your sheet as well. So the first line that I'm going to draw, I'm going to start at the top of my object and go to the mirror. And I want to make sure that this line is parallel to the principal axis. Now once this line hits the mirror, I'm going to then shift my ruler so that I can line up this point as well as my focal point. So I want to arrange or hold my ruler so that I can draw a line from the point where this line meets the mirror and the focal point. So I've drawn my line looking like this. Again, remember that when you're on the reflective side, if you draw a line, you're going to draw it as a solid line, but behind the mirror, on the opaque side, you're going to draw it as a dotted line. So that's my first set of lines. So just to recap, I started at the top of my object, I came towards the mirror. The point where I met the mirror, I lined up with my focal point and then drew a line that way. The second line that I'm going to draw, I'm going to line up the top of the object with the focal point. And I'm going to draw a line, but only stop once it hits the mirror. So I'm lining up these 2 points here, but only drawing a point until it hits the mirror. And then it's going to be a parallel line to the principal axis going backwards. I'm going to extend that line behind the mirror as well so that I have a line looking like this. So in my second line, I lined up the top of my object to the point F. I drew the line until it hits the mirror, and then it reflected back parallel to the principal axis. I continued that line as a dotted line behind the mirror as well. Now my third line, I'm going to line up the top of my object to the point C, or center of curvature, and then I'm going to draw a line that way. So this is just a line that is reflected off in the same way. That's why I've got an arrow facing both directions. And then also noting exactly as I've done before, on the reflective side, it's a solid line. And on the opaque side, it is a dotted line. These dotted lines are meeting together, and that is where my image is going to be produced. So let's describe the image that's produced using SALT. So the size of the object, the size of the image. So the image is smaller than the object that we started off with. So S is smaller. The attitude, it is upright. They're both facing the same way. The location, you can describe it in two ways. One being it's behind the mirror, which is true, and the other that it's between F and the mirror as well. Lastly, we're on to type. So again, from all that we've mentioned about real and virtual images, in this scenario, all of the reflected light that's coming back, none of them converge to make an image. Instead, our brain makes an interpretation of what or where those lines will meet behind the mirror to create an image. That is why this is a virtual image. So again, to summarize the SALT for a convex mirror, I've got this chart there, fill it in. The size is smaller, attitude is upright, location's behind the mirror, and the type is virtual. So that was a very long lesson. You probably have to go back and listen to that and try to understand that again. So there is no homework questions. I just really need you to know all of these scenarios really well. So your only homework for this is to try and really memorize and understand all of the lines that you have to draw.